Welcome everyone to this lecture on regular expressions. Let's imagine that you needed to search a string for a term, such as the string phone. Well, you can easily use the in operator keyword to do this. You could just say, is the string phone in this larger string, such as is the phone here, and it will return back true with Python. Now imagine you needed to find a telephone number, such as 408-555-1234. Again, you could use the same sort of information. You would say the string you were looking for, in, and then the larger string you wanted to search, and that will return back true as well. But here's the problem. What if you actually don't know the exact phone number you're looking for? You just know the general format of a phone number. Or if you wanted to find every phone number in a specific document, or every email address in a specific document. You know that certain types of objects always hold the same format, like dates, email addresses, or phone numbers. What we need is a regular expression in order to actually search for the pattern of what we're looking for, instead of any specific sequence. Regular expressions allow for pattern searching in a text document. Now, the syntax for regular expressions can be really intimidating at first. So here is the actual code for the regular expression of searching for a phone number. And if you take a look at that, it's kind of unreadable if you don't know regular expressions. But hopefully, after this lecture, you'll be able to build an understanding of what that actually means. So the key thing to keep in mind is that every character type has a corresponding pattern code. For example, digits have the placeholder pattern code of \D. The use of backslash allows Python to understand that this is a special code and not the letter D. You can then combine this with other special character codes in order to find any sort of pattern you can think of. So if we take a look back at this example, all this is actually saying is find 3 digits, then a dash, then another set of 3 digits, then another dash, and then a set of 4 digits, which is the format of a phone number. Okay, so let's learn how to create our own regular expressions for finding patterns in text by hopping over to Jupyter Notebook. Let's begin by understanding how to use the actual regular expression library that's built into Python. First, I'm going to make some text that we can search, such as the phone number of the agent is 408-555-1234. And then we'll say call soon. And notice there's a period immediately after that phone number. So what I could do is say, hey, is phone in text? And that returns true. I can check if a string is inside of another string. And if I happen to know the actual phone number I'm looking for, I could, as we previously mentioned, just run, is this number in here? What I still don't know how to do without regular expressions is search for, is there any phone number with this particular format inside of this text? So let me show you the format for actually running a regular expression, and then we'll go over some common pattern designs. So we're going to say import RE, and that's the regular expression library that's built into Python. No need to download anything for that one. And then the pattern we're going to be looking for, we'll just say it's the string phone. And the way you use the regular expression library is you say RE, search, and then you pass in your pattern and the text you want to search. And then you get back this match object. And there's lots of different methods and attributes that this match object has. So for example, if I call my match and set that equal to a regular expression search of a particular pattern in my text, I can then ask for information off my match, such as the span. And it goes from 4 to 9. So what that actually means is starting at index 4 of this string, so 0, 1, 2, 3, 4, we can say that's the P for this pattern. That's the phone. And then it goes up to index 9. So we can see here it actually located the span of that actual pattern. And then we can ask for particular things. And if you hit .tab, you'll see quite a lot of attributes. But some of the more common ones are asking for the start of the match or the end of the match. Now you'll notice is if the pattern occurs more than one time, so if we say my phone is a new phone, so I redefine text there, let's go ahead and make another match and then say RE search for the pattern phone inside of this text, if you ask for span, unfortunately, if you just say RE search, it's only going to find the first instance, which happens starting at index 3. It's not going to tell you that there's 2 of them. Instead, if you want to find all the matches instead of just the first instance, the correct code is RE find all. And again, we can pass in whatever pattern we're looking for. So again, the pattern here is just the string phone. And then we search that updated text, and we can say all matches is equal to this. And if you check out all matches, it's going to return back the strings, but what you could do is check the length of this list, and it'll tell you it has 2 matches. Now, if you actually want to find match objects instead of just a list of the matches, which isn't very useful, what you can say is re.find iter, and then say whatever pattern you're looking for, in our case it's phone, whatever text you want to search, and then you can actually iterate for that. So you could say for match in re find iter, go ahead and print the span of that particular match. So this is essentially returning an iteration of all those match objects, which were these specialized objects that we saw up here, which had various attributes such as span, start, and end. So commonly, you're going to see us use re find all if we expect there to be more than one match in the actual document. But re search is going to return back the very first match, which is good in case you wanted to know if it actually exists. In that case, you only care about one instance. Now let's go over some patterns. We learned how to search for a basic string, but we actually want to search for generalized patterns, not just specific strings, because we may not know what specific string or sequence of letters we're looking for. Instead, we just know a general pattern, such as the general pattern of an email address or a phone number. And before you continue, I'd highly recommend that you check out underneath the Python Text Basics folder. If you open up the Regular Expressions notebook, there's tables in here that go over a lot of what we're discussing, because usually people don't memorize the patterns unless they use regular expressions all the time. If you scroll down, we've provided easy-to-use tables that reference the specialized character, the description, an example pattern code, and an example match. And if you keep going down, you'll see more for quantifiers, which is essentially different amounts, and then another one for groups, and as well as a couple of examples here. Okay, so the first one we're going to talk about, and I'm going to hold a little bit on this part of the notebook, is underneath patterns, we're now going to look for identifiers for characters and patterns. So there's various characters, and notice that there's a backslash on all of these, basically telling Python, hey, I don't mean the actual letter D, I mean this specialized character D, which D is for a digit. And so you can see here an example pattern code could be file underscore, so I'm looking for file underscore, and then I just say \D, which essentially means any 2 digits. So an example match here could be file underscore 25 or file underscore 43 or so on. Basically any string that starts with file underscore and then 2 numbers. Hopefully you can see that this is already extremely useful. We also have alphanumerics, which is any alphabet letter or any numeric. So in case you're looking for any series of letters and numbers, you can use an alphanumeric. There's also white space. There's a non-digit, so capital D stands for a non-digit, essentially a letter. There's also non-alphanumeric, which is kind of just punctuation. And then there's also non-white space, anything that's not white space. So these are the general characters and possible identifiers that you're going to be using. So let's go over a few examples of actually running these in order to search for a generalized pattern. So if we come back up here to our notebook, so far we've only been searching for strings that we know, such as searching for a pattern. But now let's go ahead and generalize this to search for something using these quantifiers. So right now, if we say our text, let's make sure we're using the right one. We have my telephone number is 777-555-1234. So I know I'm looking for a phone number, but I don't know what phone number I'm looking for. So I need to say I'm looking for 3 digits, a dash, another set of 3 digits, another dash, and then a set of 4 digits. So the way I can do that is by defining my pattern, and I set that equal to, and in order for Python to understand that it's a specific pattern regular expression string, you start off with R outside of these quotes. And then you pass in the pattern you're looking for. So we're going to have \d 3 times, then a dash, \d again another 3 times, then another dash, and then \d again 4 times. So now we have a generalized pattern that looks for 3 digits, a dash, another set of 3 digits, a dash, and then 4 digits. So I can say now, phone number is equal to RE search, and I'm going to search for the pattern inside of that text. And what this does is it returns back my actual matching object. And it tells me where in the actual document it found it, as well as the actual match it found. And if you actually just want this information, the actual match itself, you can say group, and it will group together everything that it found to be matching. So in this case, it's this phone number here. Keep in mind, if I were to change my text, so I'm going to say text is equal to, and I'm just going to copy and paste this. Let's go ahead and change this to be another set of numbers like 888. This regular expression is just looking for a generalized pattern, so it's actually still able to find it. Again, I'm just using re.search, and if you wanted to find multiple phone numbers here, you could say re.findAll, and it would be able to return back all the matches. And if you want to iterate through those matches, you can use re.findIter. The main idea is that utilizing these sort of tables, you can then create any sort of pattern you can think of: digits, alphanumerics, white space, non-digits. Now, because it's really common to see a bunch of alphanumerics in a row or a bunch of digits in a row, it's kind of annoying to have to type \d a bunch of times. So the next set of patterns we're going to learn about are quantifiers. So we know special character designations. We can now use them along with quantifiers to define how many we should expect. So here we have a character. Plus means occurs 1 or more times. Having these curly braces with a number means occurs exactly 3 times. So you put in your special character code and then curly braces how many times you want it to occur. So this says any non-digit, a capital D, that occurs exactly 3 times. So something like ABC. And then we can say occurs 2 to 4 times. So you can give actual ranges by saying a number for the low range, comma, and then a number for the high range. You can say a number, comma, and then no other number for something X or more times, like 3 or more times. An asterisk, this is not too common to use because it says occurs 0 or more times. So that essentially means it's occurring either 0 times or more than 0. So that's maybe a little too flexible for a lot of use cases. And then a question mark is once or more. Okay, so let's go ahead and convert that telephone number here using those quantifiers. So I'm looking for a group of 3 digits, a dash, 3 digits, a dash, and then 4 digits. So a good use case for this one as far as quantifiers is probably this pattern right here. A set of curly braces, and I know I'm looking for 3, 3, and 4. So I'm going to redefine this to be the following. I can basically efficiently write this pattern saying R, and you can use double quotes or single quotes. Then say \d, and instead of writing it 3 times, I'm just going to use my quantifier, which is curly braces 3, to say I'm looking for 3 digits, a dash, another set of 3 digits, another dash, and then a set of 4 digits. And if we take a look again for this, I can say re search for the pattern in the text, and it was able to find that updated match. So it's usually more efficient to write something like this than to write something like this. But if you were to jump straight into this with regular expressions, you can see that regular expressions can easily become very difficult to read. But keep in mind, you can always just break it down using the tables that we provide. And you can always use .group in case you actually want to find the actual object or the pattern that matched. So I can say, again, my match here, and you have the specialized match objects with a bunch of different attributes and parameters here that you can explore. A really useful one is just grouping it together to find the actual match. All right, so that's the basics of identifiers and quantifiers. Again, I highly recommend you check out the tables that we provide for patterns. You can now essentially build any pattern you want using identifiers, looking for specific types of characters like digits, alphanumerics, or whitespace, or their reverse opposites, non-digits, non-alphanumerics, and non-whitespace. And you can combine those with quantifiers, knowing exactly how many you want to expect or some sort of range that you expect. Coming up next, We're going to continue our discussion by talking about groups, talking about additional syntax such as OR operators, wildcard characters, and then starts with and ends with. We'll see you at the next lecture where we talk about these other various regular expression topics.